main consultant.
The canopy drawings did not have any reference to the special tolerances or adjustable connections that really were necessary to build these structures. They had reference only to the standard tolerances that are in the American Institute of Steel Construction Code of Practice. There was no reference to architecturally exposed steel structures, nor was there any other special tolerance or adjustable connection specified.
In the original engineering plans, specifications for the canopy steel refers to the canopy as a special structure.
There is no significance in calling a structure special because such a term is not recognized in the industry as it relates to the codes and classifications of the steel structures. However, there is a term called complex structures that is recognized in the industry that may require certain pre-qualifications as well as special care to be taken both in fabrication and erection of that structure. However, unfortunately, there was no reference made to it in this specification.
Walsh contends that if the structure was classified as a complex structure, their approach and bid would have been considerably different.
It reached the point in the summer of 2003 that there were daily conference calls held between the fabricator, the fabricator's engineer, Carlo Steel, Walsh Construction, TOK, that's the DOA's construction manager, Murphy Yan, the architect, and WSI, the engineer of record. Daily conference calls to resolve issues that were not clearly shown on the construction drawings.
For Walsh Construction and their subcontractors, this additional work added extra engineering design time and delays. The absence of column deflection analysis and design delayed canopy construction further.
Column deflections are not shown on the design drawings. The fabricator's engineer, in building his model and loading the model, noticed that the columns deflect, which led to questions to the engineer of record. Did this matter?
Engineer of record had shown on the drawings expected deflection of the canopy under its own weight. And that's a very significant number that needs to be used by contractor in order to compensate for it when he is building the final canopy structure. However, our analysis shows that they used a wrong model. They forgot to include, or maybe they did not want to include because of complexity of the analysis, they did not include the composite section that includes the top plates.
The default specifications in the original engineering drawings proved to be inadequate for the canopy design.
I believe many of the requests for information we sent in at the beginning of the project were simply not answered, not due to ignorance, but not on purpose, that TOK simply didn't have the ability, the technical ability to handle this problem.
These miscalculated deflection variations on the original engineering plans could have resulted in a significant error of several inches when the canopy was completed.
By not specifying expected horizontal deflection, nor having a special adjustable connection between different elements of this structure, then miscalculating the vertical deflections by the engineer, the tip elevation and location could be off 6 to 8 inches in any direction.
A 6 to 8 inch discrepancy in the cantilever tips could have resulted in buckling and distortion of the entire top plate of the canopy. The same issue would have occurred with the curtain wall had Walsh not implemented an adjustable connection for the cables.
There was a need for tighter tolerances or adjustable connections between some of the structural elements in order to build the canopy with the geometry that was intended by the engineer.
To compensate for the incomplete and inaccurate engineering drawings and complete the canopy correctly, Walsh was forced to spend considerable extra time, manpower, and expense erecting the canopy.
The deflections that were listed on the drawings were misleading, and they made contractor spend all kinds of time and money trying to meet those deflections.
Deflection discrepancies on the engineering plans forced Walsh to erect the columns out of plumb and in order to ensure that the cantilever tips would align properly, had to continually field measure and adjust the canopies at a number of different points. The fabricator had to custom fabricate each infill piece for the openings to assure the canopy would be straight and aligned. This had to be done for all 420 wing sections.
There are hundreds of feet of weld not shown on the design drawings that each required 20 to 30 passes. This is 1.25 to 1.5 inch thick material.
The city of Chicago hired an independent engineering firm, the Thornton Tomasetti Group, to evaluate the canopy structural steel issues. The Thornton Tomasetti Group concluded the public bidding process did not allow for proposing alternatives to simplify fabrication prior to bid award, and because tighter tolerances and extensive post-fabrication work on members have cost and time implications, they should have shown in the contract documents before the contract price was fixed.
The bid documents miss 5 major points of design that severely impacted the canopy work at O'Hare. They omitted deflection information. They didn't show that the columns deflect under dead load. The deflection information that they showed for the canopy wings, the vertical deflection, was incorrect. They didn't provide a median temperature for the fabrication and the erection of the structure. They didn't show any connection details. And they didn't consider issues that affect the constructability of the welded structure.
Thornton Tomasetti further supports Walsh's claims, finding that the contract documents did not include practical provisions for realistic fabrication, erection, and thermal adjustments. The contract documents provided guidance on tolerances and connections that were inconsistent and unrealistic. Also, the contract documents did not incorporate adequate information regarding the erection approach anticipated in the design, realistic provisions for field erection, and adjustment consistent with AISC standards and industry practice.
All that we're asking for at this point is that we get fair and reasonably compensated for these changes in a timely fashion so that us and the rest of our subcontractors can continue and finish the project.
Walsh Construction has done everything within their power to overcome these obstacles and have been proactive in finishing the project.
We spent probably a year, 2003, working out the completion of the design with WSI in a proactive measure to help them figure out what we needed to do to finish the project. That all should have been done prior to going out to bid. That's the job of the construction manager, to make sure that the drawings are complete and they're biddable, and it's to protect the City of Chicago's budgets from extras that come up.
The independent analysis provided by Thornton Tomasetti clearly supports Walsh Construction's claims, and had Walsh Construction been provided with accurate and clear drawings, they certainly would have bid the job differently to account for all of the additional labor and material. The cost to Walsh and its subcontractors totals $24.9 million.
The structural steel design for the canopy on this project was not a full and complete design. There is no simpler way to say it. It was not full and complete. There was missing weld information. There was missing weld location information. That design not being complete is something that a designer should not be allowed to get away with. Owners pay designers a lot of money, and they pay them a lot of money to do things properly. This design was not done properly.